Good afternoon. I was going to speak about BIM from the theoretical point of view, but Sergio has already spoken about it for a long time. So I'm going to present a personal experience with BIM. It's better because there is the theory about building information modeling and its relationship with facility management, but it is also important to talk about practice, the problems that may come up and how to solve them. These are basic concepts. The building information modeling is different from graphic and architectural design in that it is parametric. It is a database, data which are intelligent, and then the added value that it contributes to FM is that we have a common database from the very beginning of the project, then during the construction and the development of the operation. For example, I have the split of the Mitsubishi brand of these characteristics from the supplier with this guarantee. This is information which is not lost along the process. It will help in the construction and the characteristics so that the whole operation is well documented. And then when something breaks down, we may find the guarantees easily. We know to whom we should report. It is a very specific thing. This is the university where I work, the UIC Barcelona. Very recently, it changed its name. It added the name Barcelona in order to promote the Barcelona brand. But it is not only in Barcelona. It is also in Sant Cugat and in another site, in 3 sites in total, with 50,000 square meters for the 3 campuses. This is a tridimensional image of the Barcelona campus. More data, about 5,000 students studying or preparing master's degree, other postgraduate courses. There are undergraduate students. I think that there are about 734 people working there. They fixed professors, educational people, and then those who are temporarily hired. But they have nothing to do with me because they are not included in occupation management. Lecture concerns a BIM environment. Everybody asked me, how were you able to convince your boss about BIM? There were a series of circumstances in the university that helped me. But for example, there was one of the 3 campuses, which was the largest of the 3, where there was no updated graphic documentation. We needed plans for different purposes: evacuation, occupation, operation, to assign spaces. We needed updated information because there were some plans about the construction phase, plans 2 years dated from 10 years before. Then there were inventories about fittings, about the different facilities, but they were not true to reality. I arrived in 2011, and when I saw what they had, I couldn't trust those documents. I had to do something. I had to be able to update them and create them in such a way that would allow easy updating. They were not updated because it was really complicated. They were in Excel sheets, they were not smart, etc. And something else that was absolutely fundamental. Before, there was a maintenance manager in each campus. It worked. He used an Excel sheet. He had a team with 3 people, then external services. And this service was integrated in the technical or hard services and in general services, a part of it. And so, having Sant Cugat and Barcelona, but I was not in Sant Cugat. Therefore, I needed a centralized system in which planning, coordination, and operation could be carried out in a centralized manner. This is basic. In these circumstances, the graphic documents, the inventory, and the BIM technology were there. I started to get familiar with this BIM technology. I realized that it would allow me to do what I wanted to do. Then, from the design of the project, going through construction and operation, it was going to be useful. What data did we need? What did we want? This is absolutely fundamental, because we have to pick up the data we need, and no more. Then it will be scalable. You can add more data. Well, for example, the engineering department may propose things to do, for example, and energetic analysis, data about the whole architecture. Well, it would be interesting to have those data for thermal studies, studies about lighting, etc. Well, it is scalable, but we should start with only what we need, and then we can feed the database. It depends on the budget you will have. Now, I have seen this. Well, actually, I saw it 1 week ago, and I would have liked, nevertheless, to show a large Excel sheet with all the data, but, well, I summarized it here. This is what I did. Well, with regards to asset management, there are data which are necessary in order to create a supply plan with data such as the service life and other data. Then I needed those data to create standards, which are very useful for maintenance and the different actions on each asset to determine what is legally authorized, what is better or worse. Then we started to manage spaces, also based on BIM technology for facility management. We needed to assign codes to the spaces. Names, for example. For the classrooms, everybody knew that classroom A502 was A502, but this didn't happen with offices. We had to assign codes according to a logical sequence, and then we had to assign codes to the type of spaces, whether they can be occupied or not, in order to determine the number of empty spaces or the capacity that the university has to place people in those different spaces to work there. Then occupation management. Later on, I will explain that I create the system. I am in the facility management, and then there are other departments that can give me more information. For example, for occupations, in this case, I needed a database about the university employees. So we must determine at this stage what was the useful database. I thought beforehand that the human resources database would be the best, but it was not so, because sometimes we lost sight about enrollments, withdrawals, etc. And as a result, the best database was the database with the dates and the emails entering and going out of the university. So we began the projects with everything we needed. We began the project in order to create the models and to establish the management system. Part one is what I have already explained. We held strategic meetings to propose the plan. Then you see things which are necessary, others that are urgent. You talk to other departments and they say that maybe you should do this and that. You have to be flexible in this stage and act quickly in order to include those suggestions. Then data collection. We have a CAD database from the 3 campus, and we had to collect data. We resorted to a team. I standardized the modeling. In the team of data collection and modeling, I resorted to students of the School of Architecture. They were young and they were cheap because they were graduate students, and at the same time they were people with a lot of enthusiasm. They were willing to take data from different spaces, no problem, and then at the same time they received training and could become the future BIM modelers of the university, and also they were involved in the project. Somebody can say in the future, well, I was part of the data collection, so they sort of owned the project. Then there was a part which was inside data collection. There was a more complicated phase. We have a main auditorium which is not too big, but nevertheless it was impossible to take data from everything that happened during the year. We took data about heights, the data scattering, we did the modeling, we did the data dump. This is very important. In the strategic meeting in the beginning, the ideal thing, the best, is for all those involved to be present in the meeting so that they may explain how this integration and data dump is going to take place, because every person is different and we have different ways of working, and it is very important that the 2 databases may be compatible. Theoretically, everything can be related in the 2 directions. Theoretically and in practice, it should be like that too, because there are different ways of nesting the families, the elements, the shared parameters, the project parameters. There are a series of technical aspects that should be very clear to everybody in order to be able to create the model in the way we need it. Then the integration of the rest of the database. We integrated the database about the employees in the university, and then the inventory of the parts in the warehouses, because we had assets with parts that are in the warehouses or on the asset itself. So we started in 2012, then a year elapsed, and the operators are saying, well, the parts, can they be inserted or not? So we had already finished the database and we were about to integrate it, and there are more databases. For example, the IT systems, network systems, data collection, connection with the switches, with the communication racks. Everything is prepared, but now the IT department will start working with the data. We'll have gigantic Excel sheets, and others will start implementing them. And then something we did later was training. It was BIM, but also FM. We didn't have a centralized FM system. We had to organize training in this. We have a coordinating department, the call center. Other requests come and and the operator working there must be well trained. And then, because she should be able to program and issue the incidences and send them to the operators must use their tablets. For some it is more difficult because they are older. I suppose that this happens to many of us. But little by little they get used, and they are very thankful to the new way of seeing things. And then, I have already explained this, but well, I'm going to skip this. We are now in the development stage, I have indicated a series of hallmarks. For example, corrective maintenance. This is not due to BIM, but to facility management. Everything is registered now with the causes of the problems, the assets. Soon we'll have the parts, the data about the parts, the costs of the incidences. So we do facility management for decision making. In the case of preventive management, due to the fact that we wanted to save, actually we saved 30%. Why? For example, the Thyssen elevator maintenance, the Thyssen company, well, we have a lot of possibilities to achieve good return of the investment. We know, and we knew that that database was going to provide a lot of benefits and big return. So, with regards to the different offices, we had to replace a chair. We would get in touch with a supplier, would make an offer, but now everything has changed. I have a database with 600 or maybe even 800 chairs. That is our problem. You go to the manufacturer and well, the whole thing, the whole operation is reduced to half the cost, the price. And this is so for all the assets. Then the management of transfers. This was very helpful in terms of efficiency and speed. We are doing that now. Each university department would do whatever they wanted. There were many changes going on that we couldn't control, but now with this common database, we say, use this database, make it a request, and we will respond to you. They are delighted because there is a database. They can immediately call the IT people, the workers that will carry the boxes or the chairs or whatever. They don't have any problems. From the financial point of view, we still don't know the cost, but the important thing is the speed. And with regards to the future, we have BMS systems, but they are not integrated in the whole process. There's in the simulation, the thermal analysis, lighting analysis. I have a lot of things to work in. So here, I will finish. I will thank you for your attention, but I wanted to add something that there is a slogan, the slogan of this university, which is a sentence from the Gospel. Veritas liberavit vobis, in Latin. Truth will make you free. I think that Peter, in the opening speech, said that 10% of our activity can be seen, but 90% cannot be seen. Perception is everything for the user. What they see is that we work 10%. And the fact that everything can be seen in a transparent way, makes us not to be ashamed of anything. It's a hidden work, but it is visible in a way, because everybody can see what we're doing. That is what is necessary for things to work. For example, for this conference to work, there is a lot of hidden work, but those transparent systems make it possible for people to see everything, and we avoid and prevent a bad practice also in the construction stage. Thank you very much for your attention.